Good morning. I guess, can you hear me okay in the back?
Yes.
Thank you. So while we get started, one of the things is, there's a feedback form, as I said. So what generally works best is right after the talk or during the talk, write your visceral feelings about the talk, what you would like, what you didn't. That's the best feedback a speaker can have. So we'd really appreciate if you could do that. We have about 45 minutes for this. I'm planning about 35 minutes of talk and then 10 minutes Q&A. Typically, these things get very exciting for people and the Q&A lasts much longer than that. Okay, I think we're good to go. So, this is a mix of technical and business talk. I'm going to go, I guess, dynamically on figuring out how, which direction to lean more. And next. So everybody's heard about blockchain. It's, according to Gartner, this is the latest hype cycle of their emerging technologies. You can see blockchain right at that peak of inflated expectations. There's a lot of hype around it. It's being touted as everything, a solution to everything, which it really is not, as we'll learn somewhat in this talk. And I think eventually we're going to go through this trough of disillusionment, and hopefully in about maybe 2 years from now, we'll be figuring out exactly when and how to really use it. So what is blockchain, right? So different people have different descriptions of it. Here's one way that we think describes it well. It's a decentralized, immutable, shared data store, right? It's also verifiable, synchronized, and secure. So the synchronized part kind of is central to any decentralized systems to be effective typically. But the key angles here for blockchain, the two important things, decentralized and immutable. Decentralized, I interpret it very differently from purely distributed, because in decentralized, the control of the system, the operating control of it is also distributed among participants. And the very important property of immutability. Now, since this is a very technical audience, I'll add the caveat. There's a little bit of nuance here. You might have heard of terms like forks, hard forks, soft forks, and all these things. So typically in blockchain, while it is treated as immutable, when it does mutate, there are two things that can happen. It can either merge, all the realities merge into one again, in a short window of time, or two realities may exist, and there is a hard fork that continues. So the immutable comes with a little asterisk at the end of it. But in different types of blockchain variants, people are addressing this differently, and we'll come to that in a second. The verifiable aspect is that because of the way cryptographic hashes with digital signatures and all of that, any person who's not even part of the team that is, say, quote-unquote, running and maintaining the blockchain, can still verify the data and its integrity on it. Right? It's synchronized at all times. Everybody sees the same exact source of truth. It's secure because it's cryptographically secured using the standard constructs that we are used to, hashes, digital signatures, and so forth. And the shared data store part is what lends one of the key benefits of it. Everybody is seeing the same source of truth in real time, and that's one of the very important features it offers. So despite all the hype, the technology itself is based on some very solid computer science research, right? The hype is around the applications of it, and some of it is unfounded, but the fundamentals of it are picked from distributed systems, cryptography, networking, and databases. A lot of concepts and solid research from these areas have been brought together by the original creator and then subsequent variants to deliver this technology. And interestingly, actually, the original blockchain that came out also had introduced to the world a very unique combinations of distributed systems, cryptography, economic theory, and a little bit of game theory, brought together to create the original model that Satoshi Nakamoto invented. So let's start from the beginning. Now, many of you might already have known about this given all the news coverage of this, but blockchain really came to fore through this paper, a peer-to-peer electronic cash system by a pseudonymous entity called Satoshi Nakamoto. And this paper was posted on a cyberpunk forum. Right? It's a little bit of history behind this. 2008 crisis in the United States, which was Typically, the genesis of it was in the financial institutions that control the economy. So a lot of these cyberpunk forums were trying to figure out now, after this crisis where these big banks are responsible for it, how do we create an alternate monetary system that takes us away from this and puts the control back into the people. It was a little bit of an anarchist vision, but also a very democratic vision. And that was kind of the genesis behind this Bitcoin that was introduced in 2008, December, or 2009, January timeframe. So what Satoshi essentially presented was, he said, the way we do banking and currency and so forth is that we have banks, they maintain these ledgers of accounts, and then when we have to send money to each other, if you're in the same bank, then the ledger of the same bank gets updated against different accounts. Or if you're transacting across banks, different banks update their ledger. There's a debit here, there's a credit there. So he said, what if we could create a shared ledger, which was not in the control of any one entity, right? And it was secured cryptographically, so that the entries in there once made cannot be changed by a minority of the people or servers that are controlling this chain. So this is what he created, and essentially in this system there are these nodes known as peers which run the blockchain and maintain the infrastructure, right? So each peer is exactly the same. It's running the blockchain protocol. It maintains a data store, which is the ledger, and each page in this ledger is known as a block, and transactions are added to this block. Now the immutability part is that each time a block is created, it is linked inextricably to the previous block, and therefore to the entire blockchain from the origin to that point. And this is done through linking to the hash of the previous block. And cryptographic hashes, as most of you would know, are non-forgeable until MD5 was non-forgeable. Eventually it was broken, but current standards at least are non-forgeable. And you cannot reverse them to find what the original content was to manipulate it. So using this technique, you kind of create a link of blocks, and the ledger is secured by a protocol that is known as proof of work, that was also created at the time of this. So what is proof of work, right? So this is this part here. So proof of work, essentially, when you have untrusted participant, you don't know who the other parties running the peers are. How do you decide who gets to write the ledger at any given point in time? So here he invented a game which is really you solve a cryptographic puzzle on which you don't have deterministic control on really being able to solve it. You just have to brute force till you find an answer. And this puzzle is designed in such a way that while no one entity can predict how long it would take them to solve it in a given round, the network as a whole would solve this on an average of once every 10 minutes, right? There are nuances to the crypto which are not part of this talk, but really what it is it's the network detects the computing power or the hash rate, as it's called, of how many peers are participating, and based on that creates a difficulty level, which is really a number. And the puzzle is that you have to take all the hashes of the current transactions and create a single hash. You take the hash of the previous block, and then you have to create, you have to iterate through a nonce, which is a random number, so that the three of these together create a hash which is less than the current difficulty level. And hash functions are not predictable, so you have to just keep guessing. The nonce, keep varying it till you hit a number that is less than the current difficulty level. If you do that, you win the right to mine or create that block. Then you put all the transactions in it, broadcast to everybody. Verifying that you solve this puzzle successfully is very easy. Solving the puzzle is very hard. That's one of the other asymmetric strengths of this. And then finally, the incentivization. So if you do manage to solve the puzzle and get to write the block, you earn a reward. This reward is also in the form of Bitcoin. And this is how Bitcoins get created in the network, right? And then they get shared among the entities that run. So there is an incentive model baked in as well. So this is the economic theory part I was telling you about. So this is how he created the concept of a shared global ledger that is maintained by participants that are incentivized to maintain it, and that is free from manipulation by any single entity. Now, Bitcoin, the truth as it's logged on this blockchain can be altered if there is a majority of participants that decide that we don't want to take this transaction that happened 5 minutes ago, we will create an alternate chain, and we have a hash computing power to kind of mine more blocks and create that chain. In that case, there is what is known as a fork, and two alternate realities may exist, and they may both continue to exist forever. As there was a fork, I think, back in July in the Bitcoin blockchain, and two chains exist now. And this is a pictorial view of what I just spoke about, that this is how blocks get created, transactions are hashed, you create this thing known as a Merkle hash tree, and then the block header, the mining with the nonce, and all of a visual depiction of what I was just describing. So, after a couple of years of this chain existing, there was another round of thought that said, what if now, and Bitcoin protocol had a little bit of scripting code attached to it. You could write simple commands that executed certain functions before and after a transaction. So people thought, what if you could write more complex programs? Programs that were immutable, once deployed on such a computing platform as they viewed it. And so that was the genesis behind smart contracts. And this first kind of became commonly known through a group known as the Ethereum Foundation. They created what is known as the Ethereum blockchain. Essentially, they built Ethereum virtual machine which runs on these peers that maintain the chain. And when you deploy a code on it, it gets deployed simultaneously on all of them, and it gets locked. So if you change the code and try to redeploy, its signature changes, and therefore it is known that you've changed it. And basically, this code is runs on the blockchain, is immutable. It produces determinate computation in response to external signals or transactions. It can control the assets on blockchain, and it has the same censorship-resistant properties that the Bitcoin blockchain had. But now you have a Turing-complete language that can allow you to write more complex programs, build more complex logic units. And this, by the way, is a boon and a bane, because you've been hearing about Ethereum hacks if you've been paying attention to the blockchain ecosystem. As recently as, I think, November 8th, if I'm not mistaken, or 7th, there was a more recent hack where somebody forgot there was a bug in there and somebody exploited it, and something like $300 million worth of Ethereum tokens are right now permanently locked and unusable. So with the power of Turing-complete languages comes a lot of potential for bugs, which Bitcoin didn't have to anticipate. It also had bugs, but at a much, the devastation was much less there. So at this point, somewhere around maybe 2014, another stream of thought started emerging, because Bitcoin and Ethereum were public chains, right? Anonymous participation or pseudonymous participation, really. Anybody can run a peer and become one of the maintainers of the network. All you needed was money to run that service. Anybody could connect to it as a client. I could run a wallet, Bitcoin wallet on my mobile phone and connect to this chain. There was no access control, there was no gatekeepers per se. So when enterprises looked at this and they said, this is great, there are so many good features about this technology, but I don't want to create an application that is public, that is without any control or gatekeeping. So then that's where this notion of taking the best of blockchain and building a access controlled closed network system which still retains some of the properties. It would not be fully censorship resistant, quote unquote. It would not be the original driver. Actually, there's one gentleman named Nick Szabo, who's one of the early 2 or 3 people who worked with Satoshi in writing some of the early code of this. When I say worked with Satoshi, he actually never met or spoke with that individual, so even he doesn't know, at least claims to not know who it is. But he puts it this way, he says, Bitcoin took the system of trust that we are all used to, which is very efficient. The way we do banking is supremely efficient, right? You just have an account, you transfer money, it's frictionless, or it seems efficient, but it doesn't do trust at scale, because it's enforced through legal regulations, through laws, through contracts that we sign with the bank, through the obligations which are enforced through non-technological means. And when you try to enforce those are not as efficient. So they wanted to create a system that was, in some sense, very, very inefficient, because you have to spend a lot of electricity and computing power to create this mining effect, and then everybody starts all over again after the 10-minute mark and mines again. So it's an incredibly inefficient but highly scalable trust system that is secured purely by technology. So the enterprise angle to this, the banks started this to begin with, but also a lot of technology companies like IBM or Linux Foundation, they said we want to also create a private ecosystem that doesn't maybe require complete security to be given by this Bitcoin-like protocol. We will still have some contractual obligations, create consortiums which will run these networks, private networks, but we want the immutability property. We want the untrusted, disintermediation of any trusted intermediary from within this consortium. We don't want somebody being a part of this workflow and bringing cost or latency purely for the purpose of providing trust assurance or integrity assurance. So they created these other projects that took the best of Bitcoin but also brought in new things. So these are known as private or enterprise blockchains. Right? So the public blockchains are anonymous, open participation. They are censorship resistant because there are so many servers that you have to shut down to really bring it down. They basically, because they are decentralized, they have to have a currency for participation. These are the tokens, and typically these tokens are baked into the protocol, so they are inherent to to connect and use. You need that token. In Bitcoin's case, it's Bitcoin. In Ethereum's case, it's Ether, and there are several other Litecoins and so forth. And these will work if there is a network effect. So for the longest time, there was just Satoshi and maybe 5 other people running Bitcoin peers, right? And they were sending money to each other, Bitcoin. Nobody cared about it. It didn't have any value. It started having more and more value to people as more peers joined. There was a network effect that was created. On the other hand, private or enterprise blockchains are typically formed by a consortium of organizations. They have verified identity admission control. It's mainly being looked at as a decentralized ledger, a record keeping, so to speak, which is synchronized and immutable, and essentially as a trusted single source of truth. That's how a lot of these private blockchains are viewed by the people who create them, the people who are building applications on them as well. So, what is the underlying model that really makes blockchain valuable, right? The single answer, if I was to point, and this is being a little glib about it, but essentially there are many things that go into it, but the heart of it is the consensus model. And in Bitcoin or open blockchains, the consensus model is brought in through this proof of work like mathematical constructs, which essentially randomize the power and randomize the control at every block, and therefore create that security. And that's how the network achieves consensus. Whereas in consortium systems, they need a more efficient and faster way. So they have looked at other models like Byzantine fault tolerance, consensus models, which have a long history in distributed systems. How does a network come to consensus? But then they found that there are too many rounds of agreements that go in to make that Byzantine consensus. So they are moving to other variants of this now, which are more around having some semi-trusted orderers within that who have simply been given the task to linearly order the transactions and then broadcast, then everybody kind of makes copies and agrees on it. So they assume that the ordering is fair, and these orderers are called orderers in maybe one platform, they're called notaries in another. But they use some form of semi-trusted aspect there. So in that sense, they have diluted the original protocol that Bitcoin or Ethereum proposed, which was fully decentralized, but that brought in efficiency. So as you can see, in the evolution as well, there is a constant trade-off here between efficiency and trust, right? So you have to sometimes give a little of this to gain a little of that and so forth. So the different consensus model, there are one stream is this proof of work. Bitcoin has one which is based on this cryptographic mining. Ethereum has another which is based on finding the right elements in a large directed graph in memory and constructing hashes out of it. There are different flavors of proof of work. Some of the Litecoins have adopted Bitcoin proof of work but made it easier, so you can do block confirmations as quickly as a minute or maybe in seconds, so you can adapt it that way. There is an interesting model that Ethereum team is working on called proof of stake. So this model brings in even more kind of economic theory and game theory to play. And this model, the premise is that if I have a large stake in the ecosystem, that means I already own a large number of tokens that drive this network, and I pledge a chunk of these to a smart contract, saying that here's my escrow, and give me a higher probability of mining the block in the interest of efficiency. And if I mine a block that has invalid transactions, or if I mine a block and then mine a next block which has a different double spending of the transactions I already spent in the previous block, if I do any of these things and the network detects it, then you basically take my escrow away and I lose those tokens. So I put something at stake, and proportionate to that stake, the probability of my being able to mine a block goes up slightly. This is a very simplistic way of describing it in a 35-minute talk. But that model is being worked on. There are a lot of critics of this model as well, saying again it dilutes the original full decentralization. But we have to still see what is the final model they come up with and how it is tested, how it is audited, and see the critique on this. Byzantine fault tolerance I talked about, essentially how to arrive. This is typically being used in this is a class of algorithms essentially being used in the consortium networks to achieve consensus in the presence of either faulty or malicious nodes or network partitions, right? So they use a much looser notion of trust than what the public chains use. So with all of this technical backdrop, right? So what can blockchain do for businesses? We switch gears a little bit to understand why should enterprises or businesses care about this. Some of the properties that we talked about help enterprises cut intermediaries out of their workflows. You have a lot of workflows. One example that we've talked to is in the mortgage or loan automation segment, just to give you a concrete example of what an intermediary does. Right? So in this case, when you create mortgage and you have all these documents attached to it, now these are all digitized, but these are put in a vault, and this vault is typically a service offered by a third party, because the customers of the primary lender don't trust them to not enter with this data once it's available. So particularly if you are selling that mortgage in the secondary market to other institutions. So now this third party is in this workflow purely to offer trust and to assure as to the integrity of the documents that were put in and that they have not been tampered with. And for that there is a cost. Now these companies are thinking, can we get rid of this, because they're not adding any fundamental value to the mortgage creation or the sale in the secondary market. They're purely there for trust. Can we replace that intermediary with a distributed ledger that we can run within ourselves and all agree on what's the truth. So this is an example of how you can disintermediate. The other thing it can do is bring efficiency through instant reconciliation. Right? So typically reconciliation occurs when two parties are trying to say, I did this, you did your part, now let's settle, I owe you how much, you owe me how much. Right? So at the end of that, when there is a discrepancy between my system and yours, then now there is a human intervention required. There are, there's a cost and there's a delays that are introduced. So if you're running a decentralized ledger in this case, or a distributed system that is based on blockchain, you're always looking at the same source of truth, so there is no question of reconciliation per se, because at any given point in time, both of you are in sync as to what's happened, and then you have agreed upon it through digital signatures. Another thing it can do is it can create essentially tamper-resistant data stores. So there are thoughts around just even you want to log certain events, create an audit trail, which is typically, today we have audit trails in a lot of systems, in security systems, in databases, and these audit trails are though managed by the entity that is running that particular system. And so there's always a chance that they can override some of the controls, they can turn them on, off selectively, and so forth. So if you simply want tamper-evident data storage, you can add a blockchain layer to it. You don't have to store all of your data on it, just the evidence of the data, so that if there is a change in the data, then the tamper evidence is provided through the blockchain. And finally, because it allows read access as well to any auditors who are trying to view what has happened in the system, this is a very simple way of providing real-time audit visibility. Okay, so I should not have said finally, there's one more. The last part is actually the most exciting one. It can help create some very new, exciting new business model which didn't exist before. Right? Peer-to-peer models, even in traditional things. Insurance, for example, or microfinance is a great example. Let's take the microfinance example. First we had the banks doing the financing, then we said, oh, there are people that need very small loans for a short amount of time, let's do microfinance. So basically then there were microfinance institutions, again a central entity that lends money and so forth. What if you have the ability that the community could come together and then could solve the needs of people? You could have smart contracts that essentially accept digital escrows of digital assets, could lend money, could collect the money back and then proportionately distribute it among people who lend it to a single individual or institution. You could eliminate a lot of the dependency on central microfinance organization and still enforce some of these digital transactions as they were intended. So this is just one example of new models. There is also peer-to-peer energy trading being thought of. Right? A lot of people are generating solar energy on their own. They typically, with smart meters that the electricity providers give you, in most countries where the smart meters are deployed, you can sell your excess energy back to the provider, right? But then you're beholden to the price that they give you. What if you could sell it to your neighbor or to the people 3 blocks down, using the utility company's network as just a transmission line, but you are now the supplier of energy in a more open market, and you could enable this through peer-to-peer smart contracts. So these are some of the examples of new models with decentralized trust you can create. Here's an interesting institutional example. This is in the domain of banking. Commercial paper is basically a short-term debt instrument that gets created. And just to create this short-term debt instrument, you have all these entities, from the investor to the issuer of the paper, credit rating agencies, the NSDL and registrar, which are the regulatory bodies, and banks involved in this, right? And physical documents today flow between these different institutions. People take physical signatures. The time to create a commercial paper is of the order of days. So you can take this workflow, and the reason for this is because nobody trusts that if I make digital copies of this and put in my vault and your vault, I don't know whether you have changed something. I don't know whether you deleted it and there's no record of it exists. Those kind of discrepancies arise. So if you have a blockchain-based system, you could build this entire workflow on it so that the trust anchoring of everything, the entire signatures, the workflow, the documents, would be logged on this chain, and therefore make things simpler. And now you can compress the time frame to maybe less than a day to issue a commercial paper. So this is the mortgage example I already talked about. Typically, not only putting the documents into the, not put the entire document there, but anchor the evidence of the document as hash onto the blockchain. But you can also use blockchain in this instance to track the provenance and the ownership history of these mortgages. And this, by the way, concept can be applied to any high-value asset. Right? People are doing this for high-value wines, for example, or diamonds. You can build a blockchain-enabled history of where something originated, who created it, and then who owned it after that, and who owned it after that, and so forth. So you can track the entire history on this chain without having to query n different distributed databases. Supply chain. So this is there are a couple of different values propositions within the supply chain ecosystem. One is the integrity or authenticity of the goods that are being produced, and the tracking and tracing of this in the supply chain as it moves from the production to, let's say, the final consumer. But the other interesting thing is just in the invoicing example I think mentioned briefly at the beginning, that if you supply me some goods and then you're raising invoices and you're saying, I sent you X and it reached you by date D and my ERP system is saying something different. So this is a case that we heard from the markets about a lot of inefficiencies in the invoice settlement process, right? So this again is a place where there is a requirement for a single source of truth that is efficient. So where blockchain would help is it does not fully replace your existing accounting and ERP system, but it's only allowing you to put the requisite information that you need to reconcile with external parties on the chain, and therefore speed up your reconciliation to make it nearly instantaneous. So Walmart did that famous pilot about a few months ago where they tracked their pork from farms in China all the way to a store and to a consumer in the United States across its entire journey. So a lot of companies like Walmart are looking at it. I'll skip this, I think I have, what, 15 minutes? Yeah, so I'll skip this and maybe talk about this use case a little bit before going into the last part. So this is a use case that we started thinking about when the government of India announced the digital locker initiative. So essentially a digital locker allows you to put all your documents in a cloud that's run by the government, and then verifiably share it with the different institutions that require it for know your customer type scenarios or for applying to government schemes and all of that. And they said we'll keep track of everything, we'll encrypt the data. The same thing that Dropbox tells you, right? That will all your data in Dropbox servers is encrypted. There's a small problem with this. One is that it's encrypted, but the entity running the system has the keys. So they can see your data, they can share it, they could lose it, somebody could hack it, and then you don't have that control in your hand. And it's a nice single target that's painted on this data, that if you hack this one system, then you have a billion people's data right here. So it has all these potential problems to it. So when we were looking at Ethereum, we said, what would be a great application? What if you had a decentralized digital locker that didn't require any single server to run? That was purely driven by a smart contract. You controlled your data. The master key that encrypts, and the master key is used to generate a bunch of keys that do transactional document sharing. The master key never leaves your device, right? Even the smart contract doesn't have it. Even the person who wrote that smart contract will never know what your data is. Your data is always encrypted, and you could choose to put it in your own Dropbox account, but client encrypted files, so even Dropbox doesn't know it. Or you could build, and we did this actually with IPFS, which is an interplanetary file system, which is a decentralized file system. You could use that as a backend seamlessly, and between an app running on your phone and a smart contract, there are no services running anywhere, either in our data centers or in AWS or any places. Just the app, smart contract, and a distributed cloud which hosts your data. So this was an interesting thought experiment that we also built as a working prototype to showcase what really this new decentralized world would look like. So that brings me to this statement from Naval Ravikant, who's the founder of AngelList and a well-known VC in the Silicon Valley. So he made this statement recently that the arc of the internet is bending towards decentralization. So what it means is essentially, while we know all of these properties of blockchain, it's nowhere close to, like, say, being a robust production-grade environment that maybe the mainframes are, right? We still drive a lot of our banking or enterprise-grade Java. I don't want to start a culture war between Java and non-Java people, but just as an example, right? But what he's saying is definitively there is a change in thinking, and it's of the order of magnitude as was the case when DARPA first started playing around with the notion of network computers, which eventually became internet and then became what we are using today. I think we are in those early stages of a decentralized computing and decentralized infrastructure paradigm change. And his belief, and I kind of agree with this, is that yes, we are definitively starting to head in that direction. And this is being driven by a lot of what is happening through in terms of censorship, a lot of what is happening in terms of data breaches. We are eventually going to head towards a system where we have more control on our data. We don't have to trust any single entity with that. So this is some of the ongoing work in public blockchains. Performance is being improved. Bitcoin network, for example, is extremely slow right now. It's of the order of 7 to 10 transactions per second, being confirmed, compared to a MasterCard Visa system that can handle 2,000 plus transactions per second globally, and is capable of doing 7 to 8,000. So there are a lot of faster networks like Lightning and other platforms that have come up which are aiming for much higher transaction throughput. there is a concerted effort to scale the blockchain data store itself. As you can see, a continually growing data store which never gets pruned is going to have a problem. And it's going to have a problem of managing latency, managing consistency, and you'll have to start sharding it. Right now, everything resides on one server. So there's that problem. There's the problem of putting private data on public blockchains. Can you build systems that have much more stronger privacy than the original openness of Bitcoin? Can you build them on public systems? More efficient consensus models. The inefficiency of Bitcoin's proof of work has been a big challenge, so people are trying to solve that. And then inter-blockchain transactions or side chains, which can exist around maybe a very inefficient blockchain. They are much faster, can do low-value transactions, and then interoperate with the primary heavy-duty chain like blockchain or Ethereum, or Bitcoin or Ethereum. So this is the work that's kind of going on in the public sphere. In the private sphere, some of the same stuff, but with a different, algorithms and so forth, around performance, scaling, confidentiality, and these kind of things. I think at this point, the rest of this thing is more of for an enterprise CIO, so I may skip that. The quick glance at this. This is the most important slide. Do you really need blockchain? Is a question you have to ask, whether you're a developer or you're a CIO or a CEO or a product officer, right? And more often than not, your answer probably should be no, because if you don't have a trusted intermediary that you're trying to eliminate, if you don't have multiple writers, if you don't have a need for a single source of truth, if you don't have a business network as part of that workflow to really benefit from this, you don't need blockchain. It's again, to reiterate, it's an incredibly inefficient decentralized system that has a very, very specific set of values. If you don't need those values, go build a standard application. It will be much better to build and maintain. And I think, yeah, that's it. So this is what I'd like you to take away from. I'll leave this out here and take questions. So I think it's more interesting to have questions than to talk. So, fire. Yeah. Sure. Are commercial banks transitioning to private blockchains, right? They're definitely looking at it. Transitioning is a big word. They're going to transition, I think probably at least it's 3 years away before core banking. You know that most of the banking is still driven on mainframes, right? So them to transition fully some of their core processes to blockchain, it's going to take time. We are at a very nascent stage right now. But every major bank where they are solved is not only experimenting, is doing that in-house. They have hundreds of people typically. They are not even outsourcing this stuff. A lot of them are doing this in-house because it's an existential threat. And actually the existential threat comes more from the public chains. Like a Bitcoin lets me transfer, whether I'm transferring $1 or $1 million from here to New York, the Bitcoin network can commit that transaction with the same transaction cost. Whereas my bank will charge me depending on what I'm doing, and it will still take 2 to 3 days, even with a wire transfer. So that is actually more of an existential threat, but also there are, in interbank settlements, for example, which doesn't have a consumer base, there is the potential threat of a software company coming in, building a decentralized solution, and taking away the trust that settlement banks today provides, or central banks provide, like the escrows which guarantees the underwriting. So that is being looked at as moving to blockchain. So therefore, every bank is looking at it very, very seriously. Yeah.
Yeah, hi. So if the use case is a closed, decentralized, immutable ledger, then where does the proof of work come in? I mean, ideally I would just like it to be at will, right, without any cost.
Yeah, so that's a good question. So there is no proof of work in the private ledger ecosystem, right? So they originally Hyperledger, which is the project that IBM and Linux Foundation kicked off, they came up originally with a Byzantine fault-tolerant algorithm. They said if you, me, and Nikhil are running a 3 tiers, then we run these rounds of consensus, which is traditional algorithm Leslie Lamport and others have invented maybe 40 years ago. And we agreed to, in this block, we are going to do these transactions. So it's kind of like voting, but not exactly voting. And then we agree on this and we build a block, right? So this was already more efficient, order of magnitude more efficient than proof of work. And this worked fine in a closed environment because we know that it's only us running the peers. Nobody can randomly do it. But even this was deemed slower. So what model they are roughly going for now is that there is maybe a group of notaries or orderers, which is a subset of us. Not even all of us are doing that. They will order the transactions and broadcast. So they're weakening the decentralized trust paradigm a little bit, but practically, while gaining all the other properties and making the system more efficient. This is roughly how to describe it, and we can discuss the nuances offline. Yeah.
Hi, morning. Basically, when we talk about the public blockchain and particularly Lightning Network, which is a work in progress right now. So in Lightning Network, a lot of work will be off-chain. So
yeah.
Do you think particularly for public blockchain there will be trust issue since Lightning Network will work most of the time on off-chain?
So I don't think it's a trust issue, and here's the reason why. So what the networks like Lightning or side chains are intended to do is you move the low value transactions to those chains and speed them up. You don't need to wait for, like today, 10 minutes for one block on Bitcoin, right? And then because of the threat of forks, you really have to wait for 6 block confirmations to be guaranteed that your transaction is locked. So that's almost 1 hour. So if you want to buy coffee for 300 rupees, you don't need to wait for 1 hour, for the threat of double spending. You can do it on a Lightning network, and then every maybe hour or every 24 hours, the Lightning network chain is anchored on the primary chain. And the Lightning network chain could handle low value transactions and commit them every 30 seconds maybe. Right? So for me to really then to have a cheating play there, I would have to run an infrastructure and do many 300 rupee transactions to cheat. So there is again a trade-off there, right? People might be willing to do that. So I'm describing it very simply. But some of these networks are emerging with that frame of mind. Can we move low value transactions to faster networks and then anchor them on the primary chain? You don't need the coffee transactions on a highly secured ledger as Bitcoin is.
Thank you.
Yes.
What is the cost of maintaining all these distributed nodes? Because it's like replicating server and data center n number of times.
Yes. So are you asking it from a private or public point of view?
Whichever.
Both. Right. So the question is, what is the cost of maintaining this distributed network? So it's a lot. Right? In fact, about a week ago there was a news article, a little bit of sensationalism that one transaction on Bitcoin takes up as much energy as what would power a home in the US for a whole week. The electricity consumed in mining. That's one transaction, not one block. So the idea there is that in a decentralized, in a public network, you are going to have to maintain a server, do these mining efforts, and then maintain the ledger. So there is disk computation, and then some electricity cost as part of the computation. Right? So the miners that are maintaining the network today have large-scale infra. They are incentivized by the value of Bitcoin and what its value in the outside market is. So that is driving their economic model, how they are participating, whether they see returns on it or not. If you and I start a server in the home, our probability of winning a block is actually very low, minuscule almost. So we will not run this. So that model is being dynamically driven by the cost and value of Bitcoin in the non-cryptocurrency market as well. Whereas in private chains, the value will be purely modeled in a way that if this is my business workload today, and this is my loss due to inefficiency, right? Or this is my loss due to intermediaries providing trust. If I do a capital expenditure and OPEX of this much amount by running a server and putting only the relevant information anchoring on this chain, then if I can save a much larger value, then I will move that workflow to an enterprise blockchain. If not, then I will just do its status quo. So that question is much more easier, can be modeled in a deterministic way. The other thing requires macroeconomic and game theoretic modeling, which I don't know, but the miners are doing it because they are seeing value. The day they stop seeing value, they will stop maintaining the Bitcoin. Yes, time's up. So I'll take questions offline.